Alright, so in our last video we talked about this designing a program check. What do you do with given a problem? Again, more of the problem than we had in the last weeks is where we just were changing the text structure around the code. Now we're given problems, real programming problems to solve. What we're going to do in the first couple of weeks is that we're going to deal with these things based upon, yes, we're going to step into it. We're going to step into it in three ways. I'm going to actually use this piece of paper right here. We're going to sit back and look at the three structures of programming. So, and then I'm going to talk about the different, what I have left here for you. Number one, the three structures of programming are sequential, okay, conditional, and iterative. Okay? You may have already know this, you may have, of course, I've actually talked about this. If you haven't, it's no big deal. But everything that we write in programming is based upon one of these three conditions. Sequential basically says I'm going to do a task. Okay? And once complete, I'm going to do another task. Okay? And I'm going to keep doing that in sequential order, top down. It doesn't know, the computer knows nothing, and that's exactly what to do, and it's going to follow the instructions top down. And once a task is complete, it will go to the next one. It doesn't do two tasks at a time, it does one task at a time, and once it's complete, it goes through. That is called the sequential structure. It's simple, right? At some point in time, you may need to ask a question. If A equals B, then we may do task and do a task, and we'll say task X, else, oops, there we go, else, do a task Z, okay, and done. That is called the conditional structure. You spend a lot of time doing that in this course, okay? You're working. That's really where the logic comes from. The final one could be is that I need to do something over and over again, and I might say do until, I don't know, x equals 10, and then I can, in my end here, I can do a task, and then loop. And I would probably somewhere in there, say x equals x plus 1, and loop. Okay? So that's the iterative structure. Now let me talk about these three structures. Here's the good news. We're not going to talk about the iterative structure in this course. The structure is talked about extensively, used extensively in programming 2. It will not be used in programming 1. So kind of remove that from your ideas if you have it. If you have the ideas, you're never going to use the English structure in programming 1. Okay? Like I said, it's part of programming, but you got to complete programming 2 to really know how that's actually used. Okay? So you use it, you use it, you use it. I tell students, I'm going to make you to death with programming 2. In programming 1, we're going to focus on primarily these two structures, sequential and conditional. Okay? And learn how to write them, and learn how to apply the logic, and be able to learn then to ask the question from a different time. That's where the logic comes in. Sometimes I can't tell you how to do that. You got to figure that out yourself. All right? During the next couple weeks, we're going to focus primarily on the sequential. So there's a traditional structure that we're going to focus on in the next few weeks. So don't try to worry about that should be adding if statement. We will get to that in a few weeks, and once we get to it, we'll get plenty and plenty of practice. After that, the rest of the course. Make sense? Okay? So let's kind of get started with, what it is we're trying to attempt. So here's the simple problem that we're going to attempt right now in this. So given a problem, this is a problem, this is what I mean. Create a program that takes three pieces of input, number 1, number 2, and number 3. And upon submission, hitting that button you created last time, I want it to display the sum and the product of the combined inputs. And number 1 be 1 plus 2 plus 3, and 1 times 2 times 2, but you need to display it. We need to calculate them and then display them. Does that make sense? Okay? That's a pretty simple problem. I put this up here for sake of an example that where we headed with this. Okay? We're going to start simplistic in this course, and we're going to build up and build up and build up. I'm going to challenge you. But by the end of this course, you should be able to do a problem that I haven't put in here. As a matter of fact, this is actually a review problem that you would do for programming too. I'm not too scared about showing it to you right now, but this problem is going to take in a lot more inputs. Okay, this is actually not an actually hard problem, a lot of input, and based upon the input, it's going to, it can basically say I want this black shredded mulch, and I can keep adding bags, and if there's a delivery, we're going to have a delivery charge on there, there's a tax, and so on. And by the time I get done, I can actually have a grand total of how many bags I want and what kind of delivery, based on if it's a zip code, and so on and so on. So these things get rather large, and that is a problem too. Okay? And the reason I'm showing you this is to kind of get you the idea of where we're headed. Okay? Your final project will be on the scope of what I'm showing you right here. That's where I'll go with you. This particular problem requires a lot of validation, it requires conditional statements all the way through, it requires formatting, it requires a lot of stuff that we're going to cover throughout this course. Make sense? But right now, we're just going to stick with our simplistic little problem right here, okay? And we're going to take in some inputs and we're going to do something with it and then display mouse. Now let's go back if you could. I did, whatever. Stumble over yourself and make a bad joke. But you know what? I got to the point I don't redo them anymore. And so you just got to put up with my bad jokes and my stumbling around. I think it's a minute more mine as I go through this. Okay? So hopefully you see these two pieces right here. So back to how to design a program. So given a problem like this, getting back to what I said before, where do I start? And where you start is you look at the problem and you ask the question, what are the inputs? Okay? If this is repetitive for you, like I said, if you've got to do the numbers, that's fine. Now we're going to do it in programming. It doesn't go away. Okay? So if it's new to you, we're going to sit back and identify the very first thing, what are our inputs? Okay? In this case here, we're going to take and get three pieces of input. Number one, number two, number three. Spelled out pretty nicely for you. That doesn't always happen that way. Sometimes you can be given a big problem and you're going to have to figure out what you need to fix. Sometimes it might be spelled out. Sometimes you have to ask questions about it and so on. Okay? But before you move on to number two in my design, how to design a program, you need to exhaust what are the inputs that are coming into my process. What am I going to add into my process? And I'm going to manipulate programmatically to create the outputs. That's what we as programmers do. So in this case here, you would write down number one, number two, and number three. Okay? Now, these particular, whoops. I have a perfect video, so they'll never get done. So you might say, okay, what does that mean? Well, these are words that represent actually a value. Okay? And so this value is going to be, it's just a word that represents it. It's almost like if I have three numbers, 5, 6, and 7. 5 would be number 1, 6 would be number 2, and 3 would be number 7. Does that make sense? We deal with these, and we'll talk about a little bit more how we do that programmatically. That's what these words are. We use words to represent a number in some cases. Okay? What we're trying to do then is look at our outputs, right? And so the next piece is that now that we know what our inputs are, and we've exhausted it, it's only one sentence, okay? Like I said, later on, a little bit later, we'll ask what are our outputs. Our outputs in this case are, let's see, the sum and the product. So the sum being the total of addition and the product being the total using multiplication, correct? Two different outputs, very important to identify. You need to make sure you read the problem and know exactly what's being asked of you. And exactly know what should be coming out of this process. There you go, 1 and 2. Pretty simple, right? That's where you start. Let's describe it anymore. That's where you start. Okay, just take the problem and start from there. And number 3 says we're going to eliminate any assumptions about the requirements. In this case, we ask questions. Given a problem, you may not know exactly what's being asked of you. And sometimes you might be dealing with a topic that you know nothing about. you like selling multiverses. If that's the case, it's no big deal. Ask the question. What does this mean? What does that mean? I'm assuming you want this. I'm assuming you want that. You want no assumptions. You want to ensure everything is factual. If you assume anything in this, you're probably going to be wrong. And so what you need to do is ask questions. Who do you ask them? You don't ask them what you're using. People paying you to write the program. In this course, you have questions about the requirements, you ask the instructor. Okay? Number 3, put outputs in logical order. There's going to come a time, and we'll get into that as we continue on and actually do more and more programming, where we're going to identify our outputs, and certain outputs need to be calculated before the next output. Does that make sense? A great example could be gross pay to net pay. You cannot calculate net pay without calculating gross pay. So you may brainstorm, put all your outputs there, but then you're going to ask the question, is there any one I need to do first over the other one? Is there any order to it? In this particular case, it really isn't. I don't know which one you saw, product or science. It makes no difference. In some of our programs, it does make a huge difference, and you need to make sure after you look at the outputs that you actually you solve the first one needs to be solved first. Does that make sense? We'll probably learn a little more as we continue on with this and see it working in more and more examples. Okay? So we're going to put those outputs in logical order. Number 5, start the pseudocode. Okay, this is the structured image. And so in this case here, I'm going to sit back and say, I need to write the actual logic to solve this problem. Always get the question, where do we start at? Well, like anything, if you're making a spaghetti dinner, you gotta go get the input. It could be the raw spaghetti and the sauce and so on, right? In this case, you say, I'm gonna go get number 1. I'm gonna go get my inputs. Number 1, I'm gonna go get my inputs. That's what you do. That's when you start at. Go get your inputs. This is the pseudocode process, okay? And then what we're going to do is we're going to solve for one output at a time. We're going to solve for one output at a time. I'll say that one more time, okay? Solve for one output at a time. I give students who get a list of outputs and they become overwhelmed. And they go, oh my God, what do I do? And I'm trying to solve for all of them at one time. No. You do that, you're probably going to get off in the course and change your majors and become, I don't know, something else, okay? And I don't want you to do that if you don't want to. So what we need to do is make sure you solve for one output at a time. Take one of the parts of the list, if it's in logical order, which in this case it is, it really makes any sense, and I'm going to sit back and focus on just the one output. Meaning, in this case, I'm not focused on sum, and I'm not going to worry about product. I'm just going to worry about sum. Does that make sense? So no matter what this list is, as long as it's in logical order, you do the first one, and the next one, and the next one. You do not even think about the whole list. Just one at a time. Why am I saying this? Because programming can get wrong, especially for new programmers. Do one thing at a time, and you'll be fine. Trust me on this, okay? So in this case here, we're going to sit back and say sum equals number 1 plus number 2 plus number 3. Cool? So basically what we're doing is taking the values that are represented by these words, and we're going to add them together, and the result of that is when you place on the left-hand side of the equal sign, okay, and the word sum. Sum would actually represent a word representing the actual value in this case. Okay? It's easy. Everything on the left-hand side of the equal sign is always replaced by the right-hand side of the equal sign. Let's say that one more time. Everything on the left-hand side of the equal sign is always replaced by everything on the right-hand side of the equal sign. You guys played around with that a little bit last week, right? In regards to replacing the contents of the text property with your map and with your whatever zip codes, okay? Now what we're going to do is replace the sum with the actual addition of those values represented by those words. That makes sense? It's the same thing. So then I sit back and I ask myself, am I done with sum? Have I solved that problem? And the answer is yeah. I know, rather simple. Let's start simple. Trust me, we'll get there. I showed you that one problem, okay? And so the next one we got to deal with, once we feel good about some, we come up here, we put an X by it, maybe we take a break, pat ourselves in the back, feel good about life, go pet the dog, I don't know, kick the cat, whatever, or vice versa. I like cats, so good cat person. Okay, and then product. Okay, so the product in this case is going to be number one times number two times. Okay? As you see, I use the plus sign to add. I use the asterisk to actual do multiplication, or I'm used to that. We'll talk about how to do calculations in Visual Basic here in another video because it's rather simple. Symbols you will use based upon what you're doing, but most of the symbols you're going to be using are quite familiar with as normal math symbols. And we don't get too carried away. There's a couple other ones out there, but I'll show you those in the math video. All right, cool. So what's my last thing I need to do? Well, what I need to do is now that I have all of this, I solve for one product at a time. I'm done for product. I solve for one output at a time. I'm done with product. I go to excellent. I go, oh, there's no more. Huh, I'm finished. If you like, you can put the words display, sum, and display sum, and maybe display type. Okay, but display okay? And that is the pseudocode. So it got us all the way down to 1, 2, 3, 4, 5, all the way down to number 6 of design piece. The next piece of this is determining variables, data types, scope, and so on. And we don't know what those are. So that's for the next video, and we'll come back to this. And I hope this makes sense. If given a problem, this is where you start. Once again, I know a lot of people that doesn't want to start on something like this. You don't want to write anything down. You want to dive right into the program. I promise you, if you do it this way, you will get done with your programs and your assignments quite quickly. And more than likely, more correct. Challenge yourself. Try it both ways. See what works and what doesn't work. But many students say, oh, Bob, you're full of it. Students and everybody in the world saying that. But then all of a sudden they come back at the end going, you're right. You were right. And I was like that way too. I never believed this would actually be bad. I'm telling you it is. So now you think through the solving of the problem before you ever dive into the program. Okay? Anyway, I'm going to leave it right here for this particular video, and I will see you in the next video when we talk about variables and data types, okay?